So 17. There's our objective function. And I look at those constraints and I see, well, this one doesn't really require a lot from me. It just is telling me I have to stay in the first quadrant. So what I want to do is get the other two graphed and figure out in the first quadrant, where are those vertices? So I'm going to color code 3x plus y is less than or equal to 7. That one I could get x, or I could get y all by itself pretty quickly, and then use y equals mx plus b to graph it. So I'll subtract 3x from both sides. Y equals negative 3x plus 7. And I do want to check out the other one right now too, because I want to know, can I go by ones, or is a bigger number going to show up on this other one? So I'll color code this one blue. And this one I'll do by standard form. So standard form would be using the thumb method to find the zeros. So 0 over the x, I'd have to divide. 9 divided by 2 would be 4.5 or 4.5. And then I do the same thing with the y. If the y is 0, this is gone, and it would have to be 9 to make it equal to 9 on the other side. So on my little grid, it looks like I'll be okay to go by ones, because this one is going up 7, and then it's going down 3 and over 1, and this one is just going as high as 9, 0, so it should be okay. That would be very good. And by restricting this, just using it all as first quadrant, that already shows that I understand x is greater than or equal to 0 and y is greater than or equal to 0. And because things were working pretty good here, maybe I'll go 1 every 2. All right, so I want to keep things color-coded. In the green, I had negative 3x plus 7. So I'm going to go up to 7. And then I have to go down 3 and over 1. So 1, 2, 3, 1. 1, 2, 3, 1. Now if I had a straight edge, I would use that. On here, I could cheat and use my straight line drawer. Like I said, I want to keep my color coding. There's that line. Now I need to go back and see which way to shade. And again, I might just go back to the original and test 0, 0. 0 plus 0 is less than or equal to 7. Yep, it is. I'm going to shade down. All right, so there is the green. And the blue was 0, 4.5, and 9, 0. 0, 4.5, 9, 0. Cheat and get my straight line drawn. Silly smartboard. So, code it. And then go back and check, should I be graphing towards 0, 0 with my shading? 0 plus 0 is less than or equal to 9. Yep, I should be shading towards 0, 0. So now, remember, this already took care of x is greater than or equal to 0 and y is greater than or equal to 0. So wherever I have that double shading is where I'm going to have to use those vertices. So it looks like right here has both the green and the blue. And maybe, because I use my straight line drawer, I might be able to find all of those vertices without So definitely 0, 0. Down here I'll run out of space. Let's see, this point right here was on our green graph, and that looks like 2.5. 5 halves, 0. This one. Yeah, I'm going to have to use the graphing calculator. It looks like to figure exactly where that is. It looks like 1.5, 4. So 3 halves, 4. So the last one would be right here at 0.4.5. So there's some of them that I'm really sure of. And that would be, I definitely know that one, and I definitely know that one. But those two are kind of iffy. So I think, well, where could I get this whole 5 halves 0 from? That was from my green graph. So if I go back, and instead of using y equals mx plus b and find the zeros instead, then I won't have to use my graphing calculator. So if I put a 0 in for x, it's going to be 7 for y. And if I put a 0 in for y, it's actually going to be 7/3. So 7/3, that's 2 1/3. So it wasn't quite 2 1/2. It was 2 1/3. Now I will fix that. So now I'm certain about this one. But the 3 halves 4, I'm not certain about that. Because again, it's just graphing, and graphing is not the best way to go. So, different things we could do. We could solve both of them for y. We could put them in the graphing calculator and find the intersection. Or I could just solve them algebraically. Now that's going to be totally up to you, because yesterday I showed you how we solved them for y. We could put them in the graphing calculator and find it. But this one wouldn't be too bad. I mean, if I multiply the top equation by -2, we should be able to get an answer really quickly. So that would give me -6x minus 2y equals -14. And this will give me -5x equals, and ends up pretty good, because that's -5. So x was actually 1. And then if we put the 1 back in either one of these, we can very quickly get our y value. So, didn't look perfect when I was graphing it, but apparently it perfectly lands at 1, 4. And now I'm absolutely certain about those. So whether or not you do it with algebra or you use your graphing calculator, you can find where those are going to intersect at. And then you're almost done. Because the last thing we have to do is grab that objective function, find out which of these gives us the biggest number and which one gives us the smallest number. So the objective function is p equals 3x plus 2y. And if I put a 0 in for x and a 0 in for y, this is definitely going to be 0. If I put 7/3 in, well, 7/3 times 3 is 7. 7 plus 0, that's going to give me 7. If I put a 1 in, I get a 1 and a 4 in, I get a 1 and an 8. 1. 3 times 1 is 3. 2 times 4 is 8. Going ahead and seeing the ones in my brain instead of talking through it. 0, 9 halves. AJ. Did I grab it off another problem? Thank you. I did. 2x plus y. Thanks, AJ. Didn't scroll up far enough. Let's try that again. 0, 0 still gives us 0. 7/3 times 2 will be 14/3, which we might want to see as a mixed number, so we can be sure we've got the biggest one. 3 goes into 14 4 times with a remainder of 2. So that's 4 2/3. A 1 and a 4 will give us 2 plus 4, which is 6. And a 0 and 9/2 will give us 9/2, which is 4 1/2. So we've got a 0, a 4 2/3, a 6, and a 4 1/2. Pretty obviously, our biggest number here is a 6. So max of 6 at 1 4, and then min of 0 at 0 0. No, just do exactly what they ask. Some of them are just find the max, find the min, and then some of them say do both. Give both those pieces. And boy, I suppose I better scroll back up here and see if this one said give them both. Even just scrolling with these problems takes a long time. Find the values of x and y that maximize or minimize the objective function. Find the maximum or the minimum. So we did both. That's one problem. One problem. Alrighty, I'm off to 18 unless anybody needs to get something off of this deck. I'm going to have to clear all this ink and try to go after that. Alright. 18. There we go. Alright, 18. Here we are. Oh, that's an interesting problem there. It says x is between 25 and 75. That's what this says. X is greater than or equal to 25 and less than or equal to 75. We didn't have to do that before. Y is less than or equal to 110. And then 8x plus 6y is greater than or equal to 720. Yeah, this one ought to be interesting. So we're going to graph this one, and it does not say x has to be greater than or equal to 0 and y has to be greater than or equal to 0. But we're going to see that's really where our shading piece happens anyway. So number-wise, I'm going to need to use a 25 and a 75 on the x's, so that tells me I can't go by ones. And I'm going to need to be able to see 110 on the y-axis. And then I see 8x plus 6y is greater than or equal to 720. Yeah, maybe I better do that one first. So that I'll know for certain where my zeros are and how high I need to go. All right, so if we put a 0 in for x, that means we need 720 divided by 6, which is 120. I want to make sure everybody sees it. Way back there is my graphic calculator. So 120 divided by 6. 720 divided by 6. That one. And then the other one is going to be 720 divided by 8. So not horrible numbers, but still awfully big. 120 and 90. So my x's have to go up to 90. My y's have to go to 110. And my little grid is 20 by 20. So it sounds like I better do 200 by 200. So 10, 20, 40, 60, 80, 100, 20, 40, 60, 80, 200. Same thing on both sides. All right, now back up to grab some of these and color code them. So in blue, I'm going to make sure that x is between 25 and 75. So that means this has vertical lines because it's x equals. So I need vertical lines at 25 and 75, and then I have to shade in between. So there. And then it said we have a strange little y business. Y is less than or equal to 110. Do that one in black. So I need to go to 110, and I have to shade everything that's below 110. So far my double shading is going to be inside this little box here, but I still have that ugly business of the green to put on here. So the green one, that was where we had, I better show you the numbers again, 0, 1, 20, and 90, 0. I'm going to cheat and use the straight. And then I have to see which way to shade on that one. So we had 8x plus 6y is greater than or equal to 720. If I put 0, 0 in here, that's not going to make any sense. 0 is not greater than or equal to 720. So that greater than or equal to has me shading outward. And now I'm looking, where is that triple shading? And it is right here. That's where all of that is happening. So look at that and think, gosh, I got my work cut out for me on the vertices here. But it's not bad because this line, I already know what x is. X is 25. So I just need to figure out if I put a 25 into the equation for the red, where it's going to land. So this was my red right here. And I know x has to be 25 because that's what that blue line was. If you have 8 quarters, how much money do you have? $2. So that's 200 plus 6y equals 720. And then we'd subtract the 200. 6y equals 520. And then we'd take 520 and divide it by 6. $86 2/3. Math 1. 260 thirds. So all we can do is divide both the top and the bottom of that by 2. But, I mean, that's good news. That's one of my vertices taken care of. So let me write down that vertex. At 25, 260 thirds. The one that we have to put in. Even better, we know exactly where this one is because the x is 25 and the y is 110. So 25, 110. Absolutely certain about where those are located at. I come down here and I see I need to know where red and blue intersect. Well, I already know what blue is. This blue is 75. So I need to see what a 75 in that same equation will give me if I have a 75 for x. So 8 times 75 plus 6y equals 720. 8 times 75. So if, well, 75 cents is like quarters. We could do it that way and then we could do it in our head. But probably most people are going to either do it the old-fashioned way or grab their graphing calculator for it. So we've got 600. and then we subtract 600 from both sides. So 6y equals 120. Divide by 6, and y equals 20, which makes perfect sense because there it is right there. So that point would be 75, 20. All right. One more vertex to go, and it turns out this is another easy one because this is 75 and this is 110. So it intersects at 75, 110. All right. 1, 2, 3, 4 vertices. We've got them. That was the hard part. Now all we have to do is put this stuff into that objective function. So I'm going to grab the objective function, hopefully from the right problem up here. There we go. C equals 8x plus 5y. And at this point, we would just punch them in. I think 3 of these I can just grab my hand calculator for, but then I'll show you how to do the 263rds, since that one has a fraction. So 8 times 25, I will do this one first. 8 times 25 plus 5 times 110. That one is 750. 8 times 75 plus 5 times 20, 700. 8 times 75 plus 5 times 110, 1150. Like I said, that last one I want to show you up here because we do have our little fraction. So we're going to punch in 8 times 25 plus 5 times 263rds. Just notice the only difference here is going to be that I'm using parentheses for the fraction. That's the only difference. 633 and a third. And again, this one only asks for the minimum, but we could certainly give them both. We have everything right here. The minimum is 633 and a third. So the min of 633 and a third occurs at x equals 25. Like I said, they didn't ask for the max, but we could also tell them the max of 1,150 occurs at 75. X equals 75. So depending on what they want. If you gave me both on the test, I would give you full points, because you're technically doing more than they even asked you to do at that point. All right, any other questions that are general questions? Because like I said, I'm not going to do those other two for you. I want to go back to and try. So if you don't need more time, or you have something that's an FAQ from previous assignments, make sure your names are on them and pass them up. And boy, we could have counted that as the lesson, except it has to be a word problem. There we go. Alrighty. So grab your packet, and you know what? Go to the front of the packet because I think I forgot to tell you to pre-rate yourself yesterday on the linear programming. So make sure you go to the front and you go to the objective that says the same thing that we have over there on the bulletin board. So just pre-rate yourself on solve problems using linear programming, okay? And you're not totally done with the homework yet, so I don't want you to go back and rate after homework. Oh, you need one of these. All right. So I I just wanted to go over this one. I don't think this is in your packet, is it? You guys have any just little teeny thing about graphing like this? Because this is what you asked me about in number 18. Could you do this now? If I asked you to. What would you do? What kind of lines? Vertical lines at -2 and 2. Then what do you do? Yes, shade. Shade where? In between, exactly. Because the numbers we want are in between -2 and 2. So we would shade in between those two. And you might run into another one of those on the very few problems I have for you for today's homework. So I wanted to make sure, if you didn't ask for 18, that we were able to at least talk about that. Make sense? So what if I did this? What would you do? Horizontal lines. Where? Good. Where are you shading? Now that would be a nice linear programming problem, right? Nice little box. Beautiful. Easy to find the vertices. It doesn't, because remember, if this is a system and we're solving both of these together, we only want those that have a double overlap. For the first one, if you're just looking at the green one, absolutely, infinite solutions. Just looking at the red one, infinite solutions. But together, we get a nice little box where it's easy to find what those coordinates are. So that would be a very nice linear programming problem, much easier than the one you guys asked for from the homework. Get the phones put away and pay attention. We've got one word problem that I really hope we can get done before we leave here today. Yes, we can do it. All right, here we go. Now this one says you're going to do what a lot of places do. You're going to make t-shirts and sweatshirts and you're going to try to raise some money. That's what you're going to do. So you're screen printing these t-shirts and sweatshirts and you're going to sell those at the Polk County Blues Festival. Maybe you're going up to Duluth. There's always a blues festival up there. And you're working with the following constraints. You have at most 20 hours to make the shirts. Ooh, 20 hours. That's not a whole lot of time. You want to spend no more than $600 on supplies. That's another kind of, because, sweatshirts are not going to be cheap, but you're buying them blank, so maybe they'll be okay. And you want to have at least 50 items to sell because you want to make some money. So I go over here and I see 10 minutes per t-shirt. That's all it takes. You put the little decal on there and you shut your machine and it's ready to go 10 minutes. The cost of the t-shirt, just the blue t-shirt, nothing on it, is $4. And you're going to charge people $10, so you're going to make a profit of $6. Then your sweatshirts over here, 30 minutes. So, you hold it down for a while, but this one maybe takes longer for it to cool off and set the decal or something. And it's going to cost you $20 for each of those sweatshirts, but you're going to make a profit of $20 because you're going to sell them for $40. So I started thinking about this, and the first place I would start is the profit. I would want to know, how am I going to make my money? And that's the objective function. So down here, somewhere, there it is, we have objective function. So obviously our X and Y are t-shirts versus sweatshirts. All right, if I see any more phones in people's laps, they are going to be mine. And I will just put them in my bird cage and they can sit there all day. Put them away. Close the Chromebooks, please. Alrighty, how much money do we make off the t-shirts? $6. How much do we make off the sweatshirts? $20. So it should be no shocker that underneath that is P equals 6x plus 21. Because that's what we want to do. We want to get money. Now, here's the problem. We don't have an unlimited amount of time. So when it comes to minutes here, notice this said 20 hours. The first thing I have to do is change 20 hours into minutes. So how do you change 20 hours into minutes? Times 60. So we got 2 zeros and 12, so this is going to be a total of 1,200. But how many minutes does it take to make a t-shirt? 10 minutes. And how many does it take for a sweatshirt? Yeah, those sweatshirts are killers, aren't they? Okay. Now, I have to think about what should go in front of that 1,200. And I think, do I have an unlimited amount of time? No, I can't put greater than or equal to. It has to be less than or equal to. I only have so much time. That's what it said. Now, the number. Anywhere in there did it say that we need to have twice as many t-shirts ready to sell as sweatshirts or anything like that? Hi, Jazz. How you doing?
Hey, bro. I'm not too bad.
No. Yep. Jazz. Yep. Alrighty. Did it say twice as many t-shirts as sweatshirts, anything like that? No. So x plus y, but it did say we had a certain amount in mind. What was that certain amount? 50. So we have to say, would we be all right with just selling 40? Did it say we want to sell 40? No, it said we want to have at least 50. So this one has to be greater than or equal to. And then there's the good old cost first. So we need to know something about money. How much money did you have to spend on this whole thing? $600. So definitely we're going with less than or equal to with that 600. So how much is it going to cost us to just get plain old blue t-shirts? $4. How much does it cost us to get just plain old red sweatshirts? $20. And then the last one is profit, but I already put that down there because I wanted to be able to write bigger. But that's not it. We have 2 more constraints. If I go into Joann's and say I would like to buy -5 blue t-shirts, they're going to look at me like I'm a weirdo. So what are the other 2 constraints we need? X is greater than or equal to 0 and y is greater than or equal to 0. So that's where we see all of them over here. 10x plus 30y has to be less than or equal to 1,200. X plus y has to be greater than or equal to 50 because we wanted to have at least 50 items to sell. 4x plus 21 has to be less than or equal to 600. X has to be greater than or equal to 0 and y has to be greater than or equal to 0. Wow. That's some big numbers. So we better figure out what we're going to have to do with our little graph here. So I'm going to start to color code. So there's my top equation. Top inequality, I should say, not equation. And it is nicely in standard form, so I can do the zeros, hopefully, pretty quickly, even though we're talking large numbers here. Because if x is 0 and this is gone, 1,200 divided by 30, or I just think 30 times something is 1,200. What's that something? It's 40. And if we don't get any sweatshirts, then y is gone, and 10 times something is 1,200. What's the something? 120. So we are going to have some pretty big numbers for the green one. Then the next one was our color coding here. X plus y is less than or equal to. Oh, we like doing zeros on those because it goes super duper fast. No t-shirts? How many sweatshirts? 50. No sweatshirts? How many t-shirts? 50. Yeah, those are the nice easy ones. And one more color. 4x plus 20y is less than or equal to 600. Again, let's find the zeros. That looks too much like a 1. There we go. So a 0 for the t-shirts. 20 times something is 600. What's the something? 30. A 0 for the sweatshirts. 4 times something is 600. A little tougher, grab a calculator if you have to. I think most of you probably put in your noggin pretty quick here. But if not, then you just grab a calculator. 600 divided by 4, 150. All right, so I'm looking at all these numbers. The last one is just the x is greater than or equal to 0 and y is greater than or equal to 0. So my x's have to go to at least 150, and my y's have to go to, oh, just 50. So that's kind of nice. So the y's we could maybe go by tens. Not the x's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we had to get to 150. So maybe we'll go by 20s. Now the graphing. So back up to my color coded. My green is 0, 40 and 120, 0. Again, if you have a straight edge that you can use, do that. Cheat and use my straight line drawer. Noise. And then we figure out where should we shade. That one was time. We did not have an unlimited amount of time for green, so we have to shade now. And I'm switching colors. The blue one, that was about how many you wanted to be able to sell. Oh, and that was bigger than so 0, 50, and 50, 0. But that one was at least 50. So we didn't want 0, 0. We wanted at least 50. That's going off this way. Shade. And then the all important money restriction. 0, 30 and 150, 0. Comes to the shading, did we have an unlimited amount of money? Makes no sense. And we're already in first quadrant, so we know x is greater than or equal to 0 and y is greater than or equal to 0. And now I'm looking on mine for red, blue, and green. Right? The good news is, two of those we know exactly what they are. We just graphed this. This is 50, 0. We just grabbed that one. That one is 120, 0. The bad news is we'd have to figure out exactly where these two are intersecting. But you know what? The colors help with that because I could use algebra to see where green and red equations hit each other and then where blue and red equations hit each other. But I'm going to cheat because of time's sake and tell you that they are at 25, 25. 75/15. And that's because yesterday I showed you how to solve those for y and put them in your calculator and find them. And then today when I went over the homework, I actually found them algebraically. So there are all of our wonderful little points. And way back up here somewhere, we had a profit formula. That was what we were interested in. Profit equals 6x plus 20y. All right, so we don't take a lot of time with this. Let's have these two rows find us 50, 0. This row, find us what we'll get for 120, 0. This row, find us 25, 25. If you plug that in, what will you get? And then this row, find the answer for 75, 15. Somebody's got to have it up there. Put your 50, 0 on there. Yeah. 300. Okay, next row, somebody I hope punched in that 120, 0. What'd you get? 720? Okay, next row, we needed the 25, 25. What'd you get? 650? Last two rows, 75, 15. What'd you get? 750. The problem said, how many t-shirts and how many sweatshirts should you make to maximize your profit? Which one? 750. Max of 750. And that's money at 75 t-shirts and 15 sweatshirts. That's not an example of truly a business trying to figure out how to use this linear programming. I don't know what is. I mean, that's exactly what they would need to do in order to make this work. All right. You know you're getting a ton of these, right? Got four. Four for you. Grab graph paper because I know it's working on me here. You guys did a great job. I mean, that was hard to sit through the too long